Number 36. A saturated solution of manganese carbonate contains 13 grams of manganese carbonate per 100 milliliter at 25 Celsius. What is its KSP at this temperature? Let's write the dissociation reaction. Okay, so initially we have 0 ions, but when we reach the equilibrium, we have a certain concentration of dissolved ions for both manganese and the carbonate. So we're gonna have plus S and plus S. It's a 1-to-1 ratio. So this is our saturated solution. So we have 5.44 times 10 to the negative 5th gram. We're gonna change this to number of moles. Okay. We have 114.95 grams of molar mass, and then we can convert the ions present, and it's a 1-to-1 ratio. And the same applies for our carbonate ion. So S is pretty much equals to the Mn2 plus and the carbonate ion. However, you also have to divide it by the 100 milliliter. Okay, on the top I'm gonna get moles of the ion, cation and anion. On the bottom I'm gonna divide that by 0.100 liter to form the big M, the molarity. And you're supposed to get 4.73 times 10 to the negative 6. And that applies to our carbonate ion as well. And our KSP is simply the product of these two concentrations, so it becomes S squared, and when you square the S, that's 4.73 times 10 to the negative 6, you're gonna get 2.23 times 10 to the negative 11. That's our KSP. So the answer must be C. Number 37, 3 metals A, B, C with solutions of their respective cations are tested in a voltaic cell with the following result. We have 3 different metals, and these will determine which has a higher standard potential. What's the order of the reduction potential from the highest to lowest for the cations of these metals? Okay, we have 3 different anodes. The electrode. When we have galvanic cell or voltaic cell, the reduction potential with higher will be the cathode, because electrons always flow from anode to cathode. So let's write it down. A is cathode. So when you have A and B is the cathode. The A is the cathode. For galvanic cell to happen, this has to be larger. In other words, the magnitude of the standard potential has to be larger. Otherwise, the redox reaction is non-spontaneous. Okay, and this should be our anode. So when we strictly talk about reduction, A is definitely greater than B. B and C is a cathode. Alright, so C has to have higher magnitude of standard potential. and A is the anode between A and C. So meaning C has higher standard potential than A. Again, if the other way, then we have non-spontaneous reaction. The only way to counter that is by applying the electrolysis, but that's not being asked here. So looking at three different inequality, the magnitude of C must be the largest, and then between A and B, A is larger, so we have in this order. So our answer has to be C. Okay, moving on, number 38. In which pair of substances do the nitrogen atoms have the same oxidation state? Okay, this is a relatively easy problem because all you have to do is find the oxidation of the nitrogen embedded here. We don't have ions or cations overall net, so it's safe to assume, or it's safe to know, it's safe to set the equal to 0 for the net neutral. So let me make them much easier. Hydrogen has +1 for A, and then plus X is what we want to know, the oxidation number of nitrogen. And then we have 3 oxygen atoms with -2 charge, and the sum of all these happen to be 0. And how about the nitrogen, dinitrogen pentoxide? We have 2 times the X plus 5 times -2 equal 0. So let's find X here. We have -6 here. Okay, let me use different color. It's not dividing. Okay, -6 equals 0, and +1 plus X. Well, X has to be 5, right? 1 plus 5, you get 6. 6 minus 6, 0. So that's the oxidation number of our nitrogen. And we form 10 here, -10. But if you push that to the right side, I have +10 and 2x. X has to be 5. Oh, so we have the answer. Both the oxidation number of nitrogen in the first molecule and the second molecule are identical. It's 5 and 5. In case you're wondering, C, nitrogen is just 0, and in this case, this nitrogen is +1 because we have -2, and it has to be +1 to make a net neutral 0. And here, let's see, we have a +2, and the nitrous acid has +3 because we have +1 and -4. You have to have +3 to set it equal to 0. And we already found the nitrous acid above, and nitric acid we already found +5. None of them are equal except A. Number 39, in the equation above, in the equation below, which species acts as an oxidizing agent? Now here's something students need to be careful, especially if they're taking the first year chemistry. Oxidizing agent doesn't mean the molecule or the compound is undergoing oxidation. It's like opposite. So oxidizing agents technically are being reduced, and they just help whatever the molecule interact with becomes oxidized. And one easy way to tackle this problem is find the oxidation number for each atom and see which one is being reduced, and that will be our answer. The plumbum, actually the lead, is 0 here, and in this case we have okay, you have -2, this is +4, okay? And on our product side, that's -8. The oxygen is -8 due to the 4 times -2. And okay, no, it's easier to see the polyatomic ion. So sulfate is -2 due to the -2 charge in the polyatomic ion, and then this lead has to be +2. Okay? So this lead, the solid pure lead, is being oxidized because of increasing our oxidation number. whereas the lead oxide, lead plus 4 oxide, is being reduced. The oxidation number decreased by 2 units, 2 electrons. Therefore, our answer is B, to reduced. Okay? So let me recap. The oxidizing agent undergoes reduction. Reducing agent undergoes oxidation. Alright, number 40. Standard voltaic cell is constructed using the copper metal in 1 molar copper nitrate and an unknown metal in a 1 molar solution of its nitrate salt. The cell voltage is 0.47 volt when the copper half cell is the cathode. What is the standard reduction potential of the unknown metal? Okay, let's write the equation and identify what's the reduction. Actually, okay, you do know the reduction happens in cathode. So when you have cathode, this is a place where reduction happens. Then we have only one choice for the copper half reaction. Copper 2 plus adds 2 electrons and you form the copper solid. And they gave us the standard potential. .34 volt. Well, since it's a reduction, we don't have to switch the sign here. It's not negative. However, when we form the oxidation, okay, reduction and oxidations are always coupled. One cannot happen by itself. Therefore, the unknown metal must undergo oxidation. So we have metal. Okay. So we can form like this. And we do not know the standard potential. But since it's reversed, we're gonna have negative in front. And I'm gonna set that equal to X. And they gave us the cell voltage, the sum of the delta E, not delta E, standard potential for each half reaction is 0.47. Okay, it's a simple algebra. You just set 0.3 minus x equals 0.47. And you look for that x. And you're gonna notice it's a negative 0.13. And that's the standard potential in the reduction form. And the standard potentials are always written in the reduction potential. So answer must be, don't forget volt, B.